Hey guys, welcome back. Doing chapter 17 problems here. First one's identify the acid-base conjugate pairs in each of the following reactions. All right. So for A, let's look what we have here. We have an H out front. This is typically an acid, right? And we have a carboxylic acid here with no hydrogen atom, right? So there's no H here, but there is H here. There's H here and no H there. All right, so that means our acid is going to be right here. And that means cyanide is our conjugate base. That means carboxylate is our base. And acetic acid is our conjugate acid. So those are our pairs. B, well, looks like we got the same species here. So one's the acid, one's the base. Doesn't matter which one. Acid. And then the other one would be the base. All right, so that means on the other side, what's the thing? What we got? Well, if one of them is going to be a base, they're going to gain a proton, right? So what I'm saying is this proton is going here to make H2CO3. So that means this is our conjugate acid. And it means this would be our conjugate base, which makes sense because carbonate has no protons to give. And C, ammonia is your base, which means ammonium would be the conjugate acid. And so there's a pair. So that means dihydrogen phosphate would be our acid. And if we look, our conjugate base has one less proton. All right. Here, D. If we look, H out in front, I have a nitrogen NH2 with no charge. Then I have NH3 with the positive, right? And so base here with our conjugate acid. That's your pair there. And then you have your acid, hypochlorous acid, with the conjugate base there. All right. E. Well, carbonate has to be a base. Why does carbonate have to be a base? Well, it has to be a base because it has no protons to donate. So then water is the acid. And hydroxide is a conjugate base. And hydroxide is always going to be a base. All right. So that's how we do number one. If you have any questions, reach out. We'll see you next time.